Hey, welcome to day 5 of using Mega with integrated AI technology. I hope you guys are having so much learning, and today we will be seeing into how to build a time tree using AI integrated Mega. Okay, so what is this time tree? Using phylogenetic tree, you can derive the timing of the evolution. You can say from organism A to organism B, how long it takes to evolve. Okay, this can be easily calculated. So here is a screenshot showing what is the specialty of mega integrated GPT. You see, when it is asked to a normal language model, it says many untrue things, many false information, which is not at all present in mega. But here, mega along with the GPT has given a clear-cut track of how to track the time tree. Okay, so today's class is all about time tree. Not only that, I have learned that many of you have a difficulty in importing sequences without cluster X. So today we will see. For as an example, what I am going to do here is I am going to show you how to identify a time tree for mycobacterium. Mycobacterium tuberculosis, mycobacterium leprae, they are causative agents of tuberculosis, TB, and leprosy. So we thought we will take a pathogen as an example today, and we will show you how to go about it. Okay. So I have downloaded the 6NS rRNA sequences of various mycobacterium here. As you can see, I have prepared a FASTA file format. I have reduced the gap in between, genus and genera. So now, without cluster X in Mega 12, it is very easy to import the sequence. Just select all, Control A, copy, alignment, edit build alignment, create new alignment, DNA. This is a default sequence. So just Control V, paste. Everything will be imported easily. Just delete this excess sequence. Now we will do the multiple sequence alignment. Okay. I would still recommend cluster X for any sequence alignment because that is a professional tool for a multiple sequence alignment. We have various models here and various formats. So we are Mega tool especially facilitate direct import of sequences into the tool. This is not possible in Mega 10 or their lower versions. So I have selected the sequences, the region where I want to trim before the first star or after the last star. I will select it. Okay. Shift N. I will select the entire region, delete it. These are the excess gap that is present in one or two sequences. So I will delete those gaps. I am looking into the entire alignment now. We are actually building a time tree today, not just a phylogenetic tree. So reducing the alignment gap, I guess the alignment is fine. So one more check, select all, align DNA, you know, just give a one more check to make sure that every alignment is done. Yes. Before the first star, no sequences, no debris. After the last star, no debris. So the alignment is clear. We can take it for phylogenetic analysis. Phylogenetic analysis, this is not a protein coding sequence. I would recommend instead of chimera 2 parameter, go for maximum likelihood with molecular clock. Okay, so I will tell you how this works. So these are the steps you have seen already in the previous classes. Okay, many people have this problem. This is a cladogram, not phylogram. Just unselect this. Okay, now you got a phylogram. Okay, so once you have a phylogram ready, so what we will be doing now is compute time tree. This is our objective today. So what has happened previously is the whatever we have fed, how can I build a time tree from a sequence alignment in Mega? There are two models, normal language model and the specific model. They have very detailedly given us these steps. Okay. From here, I will show you how to build a time tree. If you see this time tree wizard, okay, load sequences done, multiple sequence alignment done, tree has been built. So it is green tick here. Now select branches where you want to study the divergence. Okay. So I want to select the root. So I will select this root. Click OK. Tree is currently rooted. Yes, it is rooted with the follow. Okay. So calibrate nodes, what it is, this is, if you know the time divergence, if you know how many thousands of years it took from a leprosy to form a type, Mycobacterium tuberculosis or a particular species in the Mycobacterium genera, how much time it take to deviate. This can be collected from the research article. If you know those data, you can add it as a constraints here, okay, which will give you much more precise result. So this depends on your domain. If you are a plant biologist or animal biodiversity specialist, you can take this calibration notes from the already published research article. For now, I do not want to give a specific data, so I will skip it here. So if you are skipping, they will not be asking for any more settings. Launch analysis. Okay. So that's how the time tree has been calculated. This, so these are not in millions of years or thousands of years. This is a relative time scale because we did not specify any particular, a particular time node. The precise results are not displayed, but this is a relative time. Okay, so it seems like among the 10 different species of Mycobacterium used here, uh, Saskatchewanese is the most diverse species. That's why they formed as they have a early divergence when compared to any other species. They formed as a separate outgroup. Okay, so that's how the time tree is converted. If you are giving us node specific values, you will see how many millions of years or thousands of years will be specified here, and you know how to export into any other image format. You can use any other format for exporting. This will give you a publishable quality data. You see, in normal language model, if you have this query, how to we'll build a time tree model using Mega, they may hallucinate. These are all the results of hallucination. Here you can clearly see that MEGA-GTP, they did not hallucinate. They precisely tell you how to build a time tree model. Okay. So today marking the last day of our AI integrated. So I feel I want to thank you guys from the bottom of heart for giving us this opportunity to share whatever little we know about this mega integrated generative pre-trained model. See, it is been published just this year. Okay. So whoever is doing any kind of DNA sequence analysis, I would strongly recommend incorporating this paper. Okay. If at all you want to read more about this AI interference, I recommend this paper, which give you much more perspective, and do cite this paper. I am very sure once you integrate this AI empowered mega into your DNA sequence analysis or protein sequence analysis, the quality of the data, or the many things are possible now, which is not possible in the lower versions are possible now. I am very sure you will have a different perspective of your own data if you are incorporating this. So regarding certification, tomorrow morning, or before 7 p.m. tomorrow, we will be circulating a Google form with a certificate number in that. You can download your certificate for completing this course, and we will be circulating a feedback form also. You are very much welcome to register your feedback. And if you have any questions, reach out to me directly. I hope today's class is eye-opening for how to import the DNA sequence and amino acid sequence directly into Mega, how to draw a time tree using these imported sequences. And you can save this file as a JPG file and use Mega GTP to interpret the data also. You can ask various questions and it can be interpreted. Okay. So certificates for this program will be provided tomorrow. I hope you had a very enriching learning experience. Thank you.